right, so in this lesson 3.3, optimization with linear programming, it sounds very complicated, but really it is fairly easy and it goes along with what we've already learned. So practical problems can be solved by using linear programming. It's a method to determine the best outcome in a situation, such as maximum profit or minimum cost. So we are going to be looking at these graphs to find those things. So yes, she's saying we might use this in our real life, definitely, because we definitely want to make the maximum profit at the minimum cost, especially if you're the one running the business. So let's go ahead and do some vocab first. The general process for solving linear programming exercises is to graph the inequalities, which are called the constraints. To form a walled-off area on the x and y plane, which is called the feasible region, or feasibility region. Then you figure out the coordinates of this feasibility region. That is, you find the intersection points of the various pairs of lines, which are called the vertices. Then you test these vertices by plugging their values into a given equation called the optimization equation. Optimization equation, for which you're trying to find the maximum or minimum value possible. So let's take a look at this first example, and I like to use different colors for each line, so that's what I'm going to do. You can do that same thing if you want to as well. So for this first one, x is less than or equal to 5. So we're going to go through the x-axis at 5, and we are drawing a solid line. Okay, there's one line. And then we have y going through 4, the y-axis through 4, and solid line. And then we have to change this one. So we're going to subtract that x, so we get y is greater than or equal to negative x plus 2, and now we can graph it. Starting at 2, down 1 over 1. And graphing that line. Okay, so as you can see, since we are less than this line, and less than this line, and greater than this line, you can see that we are overlapping this region here. Now, what we want are our intersection points, or our vertices here. So we want this one, and this one. All right, so what are those? We're going to put them over here. So those are negative 2, 4, 5, 4, and 5, negative 3. So what we're going to do is now plug those values in to what's called the optimization equation. And what is that? Well, it's up here. Oh, fire alarm. All right, so we're going to plug this into our equation there. I'm going to go ahead and rewrite that up here just so that we have it. Okay. 3 times negative 2 minus 2 times 4. And what do we get? Negative 6 minus 8, negative 14. So this is my output. This is my input. 3 times 5 minus 2 times 4. That's 7. 3 times 5 minus 2 times negative 3. That's 21. So now we can see which one's the maximum, which one's the minimum. Well, our maximum would be 21, minimum, negative 14. Not too bad, right? All right, let's go ahead and have you try. Actually, we're going to do one more together. then we'll have you try one, because this one already has a change to it. And we're going to change this to a y. There we go. That way it'll be much easier to work with. So let's graph our first one after we change it. So we're going to subtract 2x, then divide everything by -1. So we have y less than, because remember we flip our sign, we divide by a negative, and then our slope here is going to be 2x, and then we have -2. Okay, so let's start at -2, going up 2 over 1, up 2 over 1. Okay, drawing that line. And then our next line, we're going to go through the x-axis at 7. So here's my x-axis at 7. There it is. And then we have going through the y-axis at 4. Trying to make that more bold. There we go. Okay, and then we have our last one, which is going to be going through the y-axis at 0. So horizontal line. Okay, now we can see how we are shading above the purple line. We are shading less than the blue line. We are shading below the black line. And we are shading below the pink line. So you can definitely see that's all closed off there. Okay, so let's find our 4 points here. 1, 2, 3, and 4. There they are. So we have 1, 0. We have 3, 4, 7, 0, and 7, 4. All right, we are plugging this in to, again, not one of these constraints, but our objective quantity. So this up here is what we want to plug that in to. So it's going to be a 2x plus 3y. All right, so let's take a look. That would be 2 times 1 plus 3 times 0. That would be 2 times 3 plus 3 times 4. 2 times 7 plus 3 times 0. 2 times 7 plus 3 times 4. So what do we get? Well, 2 plus 0, 2. 6 plus 12, 18. 14, 0 is 14. 14 and 12 is 26. So the max is 26, minimum 2. All right. Looks like you're going to try this next one on your own, and it's already graphed for you, and the points are already labeled. So you're going to go ahead and plug those points in using this formula, find your max and min, and then check when you're ready. All right, hopefully you got 5 for your max and -6 for your minimum. All right, if you've got some highlighters, that's going to be really beneficial to you in this next example. So we're going to look at landscaping. We have a company talking about some pruning and mowing jobs. So I'm going to go ahead and highlight some important pieces of information before we get started. And the first one is going to be when the crews mow lawn and prune shrubbery, it looks like they have an hour for mowing jobs, and they have 3 hours for pruning jobs. And each crew is scheduled for no more than 2 pruning jobs. So I'm going to keep that the same color as my pruning jobs up there. And they can't be scheduled for more than 9 hours per day. That's the maximum. That's a lot. A lot of hard work. The next thing is going to be how much money. So mowing lawns is 40. I'm going to keep that the same color as the mowing up here. And then we have how much pruning they charge for that. So we're going to go ahead and first define our variables. So that means the two things that we have, I'm going to make X mowing, Y pruning. All right, now let's write a system. So we have our 1 hour, 1x, plus 3y, and now that deals with hours. So remember what's our maximum hours? 9. Can't go more, so less than or equal to 9. Okay, the next thing was we had 2 pruning jobs per day. So 2, we can't do any more, so y has to be less than or equal to the 2. The other thing is, since this is real world, we can't have any negatives. So we're going to make x greater than or equal to 0 and y greater than or equal to 0 because we can't do negative jobs. That's not possible. So think of it all as being positive. So what we're going to do next is write our function to be maximized. Well, that deals with the money. So here we have how much it's going to cost. Well, it was $40 per x plus $120 per y, and that is our f of x comma y, money. Okay, so let's go ahead and graph that on this page here. So remember, our first one was x plus 3y is less than or equal to 9. So we're going to go ahead and get that into slope-intercept form. So I'm going to do that off to the side here. So x plus 3y less than or equal to 9. So subtract x, 3y less than or equal to negative x plus 9, divide everything by 3. So y is less than or equal to negative 1/3 x plus 3. All right, so let's graph that and graph the others, and then we will take a look at answering our questions. All right, so I went ahead and graphed it. We go through 2, we go through 0, we go through 0, and then we graph our pink line, which was over here. So I'm highlighting these 3 points because 0, 0 isn't going to actually get us anything because that's doing 0 jobs. So that's not going to be good. So we've got 0, 2, we have 3, 2, and we have 9, 0. And remember what our equation that we wanted to use was the 40x plus 120y. So when we plug those things in, 40 times 0 plus 120 times 2, and we go through, we get 240, 360, and 360. So it looks like selecting the greatest amount, we have 2 of them, 360. Well, 3-2 gets us 360, and so does 9-0. Well, what does that mean? What do those answers mean? Well, remember, our x was the number of mowings. So if we write this in sentence, 3 mowings and 2 prunings earns $360. And 9 mowings also earns $360. And you could add in there that there were no prunings on that one, but those 2 are going to be your maximum profit. All right, make sure to write any questions that you have down below here, and be sure to ask those in class when I see you.